Hello and welcome dear learners to the NPTEL course on Nutritional Epidemiology, a way towards a healthy life. For the Module 3 Dietary Assessment, Nutritional Status and Measurement Error for the Chapter 29, we will be studying about biomarkers in dietary assessment. So what are biomarkers? The types of biomarkers, biomarkers of intake and biomarkers of status. Advantages over self-report methods. Limitations and cost issues and case discussion for the biomarkers. So, what are biomarkers? A biomarker is a measurable biological indicator found in the body tissue, fluids or excreta that reflects a dietary intake, nutrient exposure, nutritional status and metabolism or a disease risk. So with this you can understand how biomarker is important as a biological indicator. According to the nutritional epidemiology, biomarkers provide objective measures of dietary exposure and nutritional status, reducing the reliance on self-reported dietary information. So there is an objective component over here which is very important to state that whatever is being reported will be giving you an exact information. Common biological samples used for the biomarkers are blood, where you can get a serum, plasma or whole blood. The second is urine, hairs and nails. Also saliva, adipose tissue and feces. So why are biomarkers important? In the traditional dietary assessment methods such as 24 hours dietary calls, food records, food frequency questionnaires and diet histories are vulnerable to recall bias, where the memory is very important. Social desirability biases are there which is very difficult to overcome. Misreporting is very common and portion size estimate errors are something which are very redundant. Day-to-day dietary variations are very common in countries like India. So biomarkers provide independent evidence of intake and can improve dietary assessment accuracy, which is a need. So you can say that biomarkers are objective, accurate and independent measure of intake and status. What is the role of biomarkers in nutritional epidemiology? You can understand it validates the dietary assessment tools, it estimates the true dietary intake, and biomarkers are used to assess nutrition status. They identify nutrient deficiencies, which is a peculiarity of biomarkers. They also study diet-disease relationship. Also, biomarkers correct measurement errors in epidemiological studies. So you can understand the whole set of advantages that biomarkers are there in nutritional epidemiology. Biomarkers provide objective, reliable and valid information. They strengthen the dietary assessment and helps understand the links between diet, nutrition and health. So there is a correlation which is made more stronger with the help of biomarkers. What are the type of biomarkers? So you can say recovery biomarkers, concentration biomarkers and predictive biomarkers. These are the major three types. In the recovery biomarkers, you can understand that they provide quantitative estimates of actual intake because the intake and excretion are directly related according to the physiological principles. As you understand from the knowledge of physiology, the biomarkers are considered the gold standard biomarkers who gives us only a few recovery biomarkers are known as making the precision about reference measures. So on physiological standards they are being proved. The characteristics comes that they are highly accurate, the direct proportional between the intake and the biomarker level. So you can say they have a very quantitative estimate. They are independent of self-report bias, which is very common in the other methods. And recovery biomarkers can be used as a reference measure to assess and correct for errors. A lot of underreporting is overcome over here, which is very common in self-reported dietary data. Now we will take the examples of recovery biomarkers. Doubly labeled water DLW measures average energy expenditure over a 2 weeks period, used as a marker of energy intake for a weight stable individual. A weight stable individual is there where you can say a average expenditure of water is being taken, H2O. Why it is being done? The individual consume water labeled with stable isotopes, deuterium and oxygen. So these isotopes disappear from the body at different rates. The differences reflect carbon dioxide production, which is used to estimate energy expenditure. Under weight stable condition, energy intake is equal to energy expenditure. What is the application? The application is validation of energy intake, assessment of underreporting, and calibration studies. Second example is 24 hours urinary nitrogen. What are the measures? Protein intake. Approximately 80 to 90% of the dietary nitrogen is excreted in urine. Thus, 24 hours urinary nitrogen can estimate actual protein intake. What are the advantages? Advantages are high accuracy and strong physiological basis. But with this, there are some limitations. It is very expensive, participant burden is more, and it requires a complete urine collection for 24 hours. So with these two examples, you can understand how recovery biomarkers make their place. Concentration biomarkers. These are the most common types of biomarkers that are used, and they measure the concentration of specific chemical or nutrient in the biological fluids. Biological fluids like blood, urine, adipose tissue. They indicate an exposure, but they are not direct quantitative measure of intake, just like the recovery biomarkers. The concentration biomarkers are highly correlated with intake but are heavily influenced by individual factors. The individual factors may be absorption, metabolism, genetics, and disease states. These are all the physiological conditions which derives to give this variation. Concentration biomarkers cannot provide an absolute measure of intake. You cannot say X milligram per ml equals to Y grams eaten. It is not possible. It cannot assess the error of self-reported intakes in a validation studies. But they are useful for assessing the relationship between a tissue's concentration and a health outcome. Now you can take the example of serum vitamins. Example, serum vitamin C or folate and its relation to the disease condition. Example, blood lipids, cholesterol or triglycerides, or serum carotenoids from vegetables intake. The third is predictive biomarkers. Predictive biomarkers estimate dietary intake through calibration equation. They derive from the control feeding studies. So you can take 24 hours urine fructose and sucrose as a marker for total dietary sugar intake. The predictive biomarkers are objective, sensitive and stable and time dependent. These are the very four important characteristics. They are useful in larger epidemiological studies. They require validation equations. It also shows that the predictive biomarkers has a dose response relationship with the intake. So you can understand with respect to dose, if you have to calculate, it is very useful to use this. It also helps in reporting errors. So you can say there are many important relationship, dose response relationship, objectivity, sensitivity, stableness, validity and helpful. So it takes a major role to state that predictive biomarkers are also important. So these biomarkers reflect exposure in the body, but they are affected by many internal factors and thus do not provide a direct quantitative measure, which is ideally found in the recovery biomarkers. What is the comparison? You can have the comparison like recovery, concentration and predictive. Out of all these three, you can say cost wise, recovery biomarkers are very costly, concentration are moderate and even predictive are moderate. The physiological basis, recovery biomarkers are strong and along with that predictive biomarkers, where versus the concentration biomarkers is moderate. Validation standard recovery biomarkers are gold standard and the other two have moderate to good in terms of taking the standardness. Measurement absolute intake is very yes as being seen in recovery biomarkers, whereas the other concentration and productivity is no to approximate. The example of recovery biomarkers is DLW and urinary nitrogen. Concentration biomarkers, it is serum vitamins, and in productive biomarkers, it is urinary sugar. Biomarkers of intake and biomarkers of status. So you can understand biomarkers of intake is indicators that reflect recent or habitual consumption of food or nutrients before the body's hemostatic mechanism heavily alter. Example, salt intake 24 hours, urea sodium, protein intake like 24 hours urine nitrogen, or fat intake showing the plasma fatty acids. Plasma carotenoids by fruits and vegetable intake, urinary sucrose and fructose by sugar intake, and alkyloresoxynils by whole grain intake. So you can understand that nutrient foods and biomarkers has a sort of a relationship where energy doubly labeled water, protein 24-hour urine nutrition, salt 24 hours urine sodium and so on with potassium, fish, fruits, vegetables, sugar and whole grains are also being stated again. Now biomarkers of nutritional status. These indicators reflect the body nutrient stores of physiological sufficiency. Biomarkers are used to identify nutritional adequacy. They have a certain sets of things to state that non-recovery or predictive biomarkers can be highly informative for assessing nutrition status. Example, vitamin D status of coming with serum 25 hydroxy vitamin D, or iodine status by urinary iodine, vitamin B status by serum B12, folate status by RBC folate, or serum ferritin by iron status. Additional biomarkers like hemoglobin, transferrin, soluble transferrin receptors. So these are enlisted to state that how biomarkers of nutrition status comes as an important. Advantages of over self-reported methods. So biomarkers are not dependent on memory, literacy or honesty. They are being as a biomarkers as a result of objectivity. The reduced bias of recalling, interviewing bias and social disability are being accumulated over here. Detection of misreporting. So the biomarkers can identify underreporting and overreporting. Example where biomarkers underreporting is higher and overreporting in biomarkers is also lesser. Underreporting of energy intake is commonly observed in obese individuals. You may have an advantage of biomarkers improve validity, better self-assessment of long-term exposures if some biomarkers reflect in adipose tissue fats or hair minerals and erythrocyte fatty acids. Also, they are useful in large cohort studies, which gives an association between diet and disease. They are also being seen that self-report requires translation via database and may contain outdated or geographically inaccurate nutrient values. So biomarkers measure the actual biological outcomes. food intake, food consumption and estimated intake. So all the self-report pathway is completed over here. Versus in biomarkers pathway, you may have a biological sample or very objectively. Biological marker analysis is done by the instrument, machine, and actual biological outcome is being stated, which is much more clearer and more objective. What are the limitations of the biomarker? Biological variability may be influenced by genetics, disease, age, sex and metabolism. Lack of specificity with respect to some biomarkers may reflect multiple dietary sources. Serum carotenoids may be coming from carrots, tomatoes, watermelon, pumpkin and even from spinach. Short half-life. Certain biomarkers reflect only recent intake. For example, urinary sodium in 24 to 48 hours. Sample collection burden. It requires blood and urine collection and laboratory processing. Also, there are limitations of storage requirements, ethical issues which gives invasive procedures and participant has to go with consent, compliance and increased dropout rates. Higher cost also adds a limitation. And comparatively, if you take about the cost of dietary assessment methods, FFQ, the cost is low. 24 hours recall, it is moderate. Serum vitamin assays are moderate. Urinary biomarkers moderate to high. And doubly labeled water is very high. Now we will go for a case discussion. A case study on validation of sodium intake assessment. In this case study, the research question was, can a food frequency questionnaire accurately estimate salt intake among the adults? Very important. The study design was taking participants 250 adults. So they can understand the difference FFQ assessment of salt intake and 24-hour urinary sodium collection. One is a biomarker, the other is an FFQ self-assessment of salt intake. The finding shows that the FFQ estimated 7.2 gram per day salt, where versus the urinary sodium estimate showed that 10.1 gram per day salt. What is the difference? The FFQ underestimated intake by approximately 29%. You can identify over here that the FFQ 7.2 and for urinary sodium it is 10.1. The interpretation was that hidden salt in processed food is more, poor recalls for the 24 hours part which is in FFQ and difficulty estimating added salt. The conclusion of this case study is 24 hours urinary sodium provided a more objective estimate of the true intake, where versus the study also states that in comparison to the FFQ assessment, it demonstrated the importance of biomarkers for validating the dietary assessment method. So, if you take the self-reported FFQ versus biomarkers, the more accuracy comes more towards the biomarkers. In the summary to this chapter, I would like to state that biomarkers are objective biological measures and they are found in blood, urine, tissue or other body fluids that provide information about dietary intake and nutritional status. Biomarkers help overcome limitations of self-reported dietary assessment methods such as recall bias and underreporting. Biomarkers can be classified on recovery, concentration and predictive biomarkers. Each serving differs different purposes in nutritional epidemiology. Example, doubly labeled water for energy intake, urinary sodium for salt intake and serum ferritin for iron status. So you can understand how it is very different for the purposes in the nutrition epidemiology. Although otherwise, the biomarkers improve the accuracy and validity of dietary assessment. Therefore, their use is often limited because of high cost, specialized laboratory requirements and biological variability. So, when combined and with the traditional dietary assessment method, Biomarkers offer a more comprehensive, more reliable evaluation of diet and health relationship. So with this, we have come an end to this chapter. You can take the help of these references, which are very useful for you to understand this topic more in detail. And thank you for the day.